That's Django. That's a lot of people. How many people use like SQL Alchemy or some other ORM? Python or not? I don't really care. And how many people at least have some like SQL familiarity? Cool. So that's like everybody, basically. Like, I'm sorry for like the 3 people who weren't raising your hand. You're not part of everybody. So I'm Alex, and I really hate the Django ORM, like probably more than anyone else on the planet does. And I'm also one of the people who writes it. So I guess everything I'm about to say is, to one extent or another, my fault. It's also probably why I hate things that other people don't hate. So it cuts a little bit both ways. So why do I hate this? Because lots of people like it. It's probably like one of the top 2 most used ORMs by the Python community, and I have hate for it that I don't think I've ever actually seen anyone else express. And if you have questions at any point, just interrupt me. So I have much hate for the Django ORM because it is not possible to execute this SQL query. And for like 3 people without SQL familiarity, the idea is you have a table called event, and you want to select all the different things from the event type column, and basically take the sum of the field called end time subtracted by the start time over the entire table. And it's not possible to do this with Django, and I think it ought to be. And it's long been said, sort of, the Django's ORM's philosophy is not that it's supposed to be SQL replacement. There is a tool for replacing SQL and executing every single query that SQL is capable of executing, and that tool is called SQL. You should check it out, it's pretty cool. The Django ORM is it's designed to turn rows in the database into objects and execute really common queries, not to replace all of SQL. And so we have to establish whether that query would be whether it even falls in the scope of Django. And so we have the question, was that a common query? And there are a few ways to look at what is a common query. There's first, maybe it's a query that that we just write a lot. We know I need to do, select fields from column where ID equals 3. That's a common query because we know we run it a lot. But sort of the alternative definition I have for what's a common query is, could we build up what we think would be the right way to execute this query with Django using the existing machinery in Django? Do we already have a syntax for it? And it turns out that Django does have a syntax for it. Event.objects values, event type, which basically says I want all the event type values from all the rows, and annotate with the sum of f end time minus f start time. We have all the event values, and now for each one of them, in addition to selecting it, we also select the sum of the end time and subtract from the start time with these funky f objects. And so we have a syntax for it. So I claim that this is sort of evidence. It is a common query because we can build it up from the building blocks we've already decided are necessary. We've decided sum is necessary because aggregates are sufficiently common queries. And these weird f references can be used for stuff, and selecting a subset of columns with values is common enough. So we have all these little pieces that are common enough, and we can build this query we want with them. Unfortunately, when you try to run it, you get this. Expression node object has no attribute split, which, in addition to telling us this doesn't work, is like the worst error message ever. Because no one on earth has a clue what that means. And so, sort of, if you read in and try to see what happens, is these aggregate objects like the sum, and there's also count, and I don't actually know what other ones exist, other aggregates. The standard deviation, that's one. They all take strings, which are the name of the field you want to compute the aggregate on. So you could say, I want the sum of all the start times, and I want the sum of all the end times. But you can't take an expression like the sum of the start times minus the end times, or anything else that's useful for building a slightly non-trivial query. And I think the reason for this is there's no real composability in sort of all these objects within the Django ORM. You have sort of sum objects, and you have these f objects that were basically designed totally independently. Sum and count and all these other aggregates were designed sort of as an object to add aggregates, to be able to ask queries like, show me all of the books that have more than 2 authors, or give me the total number of authors in my table, or give me the sum of the salaries for all the developers in my table, something like that. That's kind of how aggregates were designed. And f objects were designed with the idea that you want to write queries that are sort of have self-referential fields. You want to say characters, all the levels for all my characters is now the previous level plus 1. Or I want to find all of the photos that have a height that is more than 2 times the width, because that's a super important query for my photo thing. So they were designed sort of for 2 different types of queries, and so they have these 2 separate designs that in no way sort of intersect. There's no sort of comprehensive system that indicates how all these different sort of clauses within the final SQL interact. And I think the result of that is sort of the lack of composability. You have these sort of 2 separate worlds that don't overlap. So by comparison, this is what the SQL alchemy query looks like. Session.query, which says sort of what you're selecting over. You're selecting the event type and the sum of end time minus start time, and we're grouping by the event type. And so there's a lot of differences between the Django query. The SQL alchemy query is very SQL-oriented, perhaps not surprisingly. But I think the really key thing is the consistent usage of how we reference a field. It's the name of the model or the table or whatever you call it in SQL alchemy land, and then you have the field you want as an attribute. It's very consistently referenced. It's the same syntax in every place. By contrast, Django doesn't have that sort of internal consistency. You have methods like filter or exclude, which take a set of keyword arguments mostly. You can say something like developer.objects.filter state equals Illinois. You have this sort of keyword argument syntax. You have these Q objects, which also use this keyword argument syntax, except for you really only use them when you want to have an object to do an OR with. If you want to say like they live in Illinois or they live in California. And so they're used sometimes. And then we have these aggregate objects. It takes strings, which refer to the names of fields. And we have these F objects that also take the names of fields. And there's sort of no real consistency. We have like 4 or 2, depending on how you count them, different ways to reference a field. Sometimes a field is inside an F object, sometimes it's a string, sometimes it's a keyword argument. And there's not a lot of consistency between how they interact. And I think that's the origin of Django's problem. Because we have all these different things, and they were basically all designed independently of each other. Django was sort of originally built at sort of a very simple ORM, and then it was refactored, and like 4 years ago we got this, like, at the time, very consistent filter, exclude syntax, and we could execute queries, mostly pretty simple queries. And then aggregates were added, and they were a little bit inconsistent with some other stuff, but they still sort of worked. And if you go and look in the Django philosophy documentation, which sort of outlines the philosophy for each different component of Django, it says you shouldn't have to import any sort of new objects in order to interact with the ORM. It should all be part of the API. So we added these aggregate objects, which you have to import, but whatever. And the philosophy wasn't that important anyway. Then we added these F objects, and they sort of don't interact with anything else, really, except in the way they were designed. And I think that's the real problem, is that instead of having any sort of comprehensive system, we represent a clause in a SQL statement with this sort of object, and you have a subclass for this thing, and you have a subclass for, if you want to have a comparison, and sort of the same sort of internals. The result is the API is sort of very inconsistent. Whereas in SQL alchemy, you have sort of this one, you get the attribute, and you do an operation on it. In Django, sometimes you have these weird under lookups. So if you want to have developers who are more than 80 years old, developer.objects.filter age under GT equals 80. And that sort of is how you represent that query, even though it doesn't actually make, it's not a syntax which has anything in common with the rest of Python. This under syntax, it's a made-up thing, which is really nice for a lot of queries, but it has no consistency with anything else. And as a result, when is it valid to use these under lookups? When is it valid to use F objects? I have no idea. They're valid when they work, and pray that you don't try to do a query that no one else has thought of, because you will feel pain. And I think a key philosophy is simple things should be simple, hard things should be possible. And I think the result with the Django ORM is simple things really are simple. If you want to just look for objects with a specific ID, or you want to do basic filtering or ordering by, that is really, really simple. I think that's a tremendous virtue, and for 90% of projects, perhaps, that's why the Django ORM is so nice to work with. If when you don't have sort of complex analytical queries, you really fulfill this promise that simple things should be simple. And then medium things are sort of mostly possible. We can do basic aggregates, we can say things like, I would like to select all the books as well as account how many authors they have. The problem is, sort of hard things aren't possible, because hard queries mostly come from combining sort of all the different pieces in weird ways that no one ever envisioned. And those aren't really possible. And truth be told, I didn't think the query I had at the beginning was terribly hard. I wrote God knows how many slides back to this. I wrote this out and I started to run my tests and I got the giant exception and I was like, oh, fantastic, this doesn't work. And that's when I started sort of reverse engineering why my thing doesn't work. Oh yeah, that's right, that just takes a string and it's splitting because the under syntax is value. That's why, so the F subtraction has an expression node and split is coming because aggregate's expected to just take a string which can contain the under lookups. Oh god, what a mess, is basically what my process was. And so, if you don't want to do all that debugging, you basically wait and see if you have an exception. If it's a readable exception, like field does not exist, oh, I made a mistake. If it's one like that, you go, oh, this just isn't supported, tough luck. Yeah. And so, speaking of things that should be simple, this is my other reason I hate the Django ORM. This is a simple query. If I would like to get the events where the start date is their hour is 10, they happen between, I guess, 10 and 11, that's really simple. Fulfills the mantra. Simple things should be simple. And things that ought to be simple, events that occur in the afternoon, I guess, because they happen at 12 or later. This should be simple because that makes sense and is sort of obvious. If you understand, you can use the under to get the hour. You understand you can use the under greater than to sort of look for things by comparison. Unfortunately, this will also blow up because the under syntax basically supports a single level of lookups, and greater than lookups are considered the same as an hour lookup. You could traverse many levels of relationship, so you could say, so if like event was a foreign key to something, you could say something under event, under start date, under hour, and that would be fine, but hours are the same type as greater than, and you can only have one of those. And I think this is just another case of this under syntax makes a lot of sense for really simple cases, but because it's totally made up and sort of wasn't designed to be consistent with anything, it's not really simple for advanced cases, or what the Django ORM sees in the advanced case, but really ought to be really simple, because that's a really simple query. So yeah, I think the syntax is really neat, and it's really like shockingly intuitive. This under is like a join or a lookup. It has no precedence absolutely anywhere in like Python, the rest of Django, or anywhere else in programming I can think of. But when you show someone like that first query, like everybody instantly got what that meant, even though that doesn't actually make any sense. Like sort of, if all you're looking at is, oh, I know how the rest of Python works, but this thing sort of works. It's like it's so intuitive, even though there's no good reason for it to be. But it falls apart when you want to write this query for reasons that aren't really good. So, sort of my conclusion from looking at all this is I think the ideals of the ORM are really good. This idea that it's not a SQL replacement, it's an API for interacting with a database that happens to use these objects and be sort of more or less nicely Pythonic. And I think that's a really good ideal, not to try to replace SQL. Although SQL Alchemy basically clearly does that in a way that a lot of people really like if they're SQL oriented. I think there's obviously a lot of space for more than one ORM, and I especially think there's a lot of space for these two ORMs with really diametrically opposed philosophies. And I think the API is really, really great for simple cases. But I think sort of the flip side is the inconsistencies bleed. The fact that you have 4 different ways to refer to a field, that shows itself because the internals start to reflect the fact that you have 4 different ways, and before you know it, these 4 different ways all take different code paths, and they don't actually work with each other because no one ever thought about how should these things interact. And it's sort of the final result, queries you want to write that feel like they should be easy aren't. And so sort of my conclusion, I think, is I think there's space for an ORM. There's a syntax closer to SQL Alchemy's, but a philosophy closer to Django's. I think there's space for something that sort of uses SQL Alchemy's expression language, where if you want to say field equals something, you do like timeline event dot start time equals 14. And I think there's space for something that uses a syntax like that that is sort of maybe a slightly higher starting point in terms of difficulty. It's not as intuitive how that sort of expression is built as start time equals 14 like in the Django ORM. So something slightly higher barrier to entry perhaps, but also has a lot more consistency and sort of keeps this philosophy of we're not replacing SQL, but we do sort of express it in a more consistent way. And I think as a result of the consistency, you can express more of it. So yeah, I think Django right now is kind of this 80-20 solution, which is good. 80% of your problem, like, I don't know what the 80 or 20 is. You solve 80% of the problems, no one cares about the 20%, I guess. But I think 90-10 is possible within the grasp of that philosophy that you're not replacing SQL, you're just implementing an API for things that the API works for. I think that's within the grasp of 90-10 or 95-5 or make up whatever numbers you like. I think the philosophy works for more problems than Django's API works. So my sort of secret project that I'll never finish because I have 80 other projects, and they all actually deserve my time because there's not like 10 competitors in their space, is to really build an ORM with an API that is more consistent, but still really has this ideal of, it's a Python thing, we're not replacing SQL, we're not implementing SQL, we just happen to generate SQL. So, thank you guys, and questions? Okay.
What does ORM stand for?
Sorry, Object Relational Mapper.
Okay.
Yeah.
You have to go back.
All over again.
So when I understand you can use SQL Alchemy in Django too, but are there gotchas? How well does it work in practice? I've never actually done it.
So sort of the gotcha is it works just fine, except all the things that you sort of assume will just work done. So the admin works because it's able to introspect all the metadata from the Django ORM. So any model that's a SQL Alchemy model instead of a Django model doesn't work in the admin. Model forms don't work out of the box. So sort of all the stuff that works by reading the metadata out of a Django model stops working, which is like a lot more than a lot of people realize. So the admin forms, fixtures and serialization, stuff like that.
What are your thoughts on the progress of the models more recently, like multiple databases, virtual models, things of that nature? Do you think it's going in the right direction?
So I did multiple database support, so I of course think it's the complete right direction, the best thing since like. No, I don't think a lot of the more recent editions, like these virtual models, things like that, or multiple database support, have added to this problem in sort of the way that aggregates or these F expressions did. I think it's mostly when we add new ways to query that have caused these problems, because it's really the querying infrastructure which I think has these inconsistencies. Sort of the rest of the ORM sort of fits together nicely like a jigsaw. And the rest of the ORM is an API that's consistent with the rest of Django, and sort of, there was a series of blog posts like 3 or 4 years ago about like coherency within a framework. And now, Django's a full stack framework, so all the pieces are sort of coherent together. But, at the time, turbo gears and pylons, and now I guess pyramid, they were sort of, bring your own for each component, so they weren't necessarily as inherently cohesive. I think sort of a result of sort of the natural growth has been pieces of Django have become less coherent with themselves, which I think is unfortunate, because I think the argument that was made 3 or 4 years ago that when all your pieces work together and look like they're designed by the same person, everything becomes easier to use. It's the same argument that what's his name makes the mythical man month. If you have sort of this designer for your code and everything is like really nicely designed APIs, it works together, everything magically becomes better because your brain is always in the right mode. I think that's true, and I think it's unfortunate that we sort of slipped in terms of having this real consistency. So where we've slipped in the consistency, I think we've made a mistake. In places where we've just added new features that don't cause problems like multiple database support, I think we've done well. Yeah.
So, again, I already introduced myself. I do Rails work for a living. So, which means I don't deal with the Django ORM. I deal with Active Record, which has its own problems. Its API is large, fairly consistent, but really goddamn big. But one of the things that tended to not piss off our really hardcore DB guys is for querying, you can learn their syntax for methods for building up a query, or you can not, and just find by SQL and throw a large string of SQL in there, and it will build models off of that SQL query. That might be yet another option that you can offer people when the Django ORM isn't good enough, if it doesn't provide that.
The last release of Django 1.3 added model.objects.raw, which
Okay.
just lets you just stick a string of SQL in there and get back objects.
Cool.
My personal curiosity as someone who writes Django is, where, when you're using that, is it just because you have a really complicated query and damn it, that's what I want to do? And where are you using that because the ORM got in your way?
Couldn't
Because it
figure out how to
failed.
use it.
Yeah, exactly.
Gotcha.
There are places where it's appropriate to use that because I'm a DB person. I know my SQL, and
Yeah.
it'd be a waste of time to like sit through combing through docs. I use this method and I combine it with that method.
Yeah.
And there are places where I'm a Python developer first, and I poked around in the docs and I gave up because I couldn't. And that's where we failed. And that's the case I'm interested in.
Gotcha. I understand.
Do you feel like the Django project is huge on trying to remain as backward compatible as possible? Do you feel like that maybe holds you back in your vision of a improved and perfect ORM, and that you can't like change the way F lookups work or Q objects or that kind of thing, or is that?
Yes, I think it's unquestionable that maintaining strict backwards compatibility has a cost, in that we can't move to new APIs when we see we're wrong as quickly. We spent 3 releases deprecating the old way, and we slowly introduced the new way. But I think that cost is not greater than the upside of, we have serious enterprise users who upgrade every 6 years who say we can use Django because we know it works, and we have developers who have been sort of working with Django for a long time and still can recognize how everything works. I think the benefits of the backwards compatibility are greater, but it's not to say there isn't a cost.
So the fools with Django non-relational gave me commit access, so I've been digging around in ORM and whatnot, and like some parts of it are very SQL centric, because I mean when it was designed, I don't think anyone thought someone trying to shoehorn MongoDB into it or App Engine. So in your grand underground spy project of redesigning the ORM, do you think like you'll try and keep in the ideal to keep kind of an abstract there, because now people are trying to use other things other than SQL behind it?
Yeah, I think if I were to try to build SQL Alchemy today, I still wouldn't try to make it work with non-relational databases, because SQL Alchemy gains power from saying we work with SQL databases. You have methods like group by, which don't make sense, even though maybe the concept of a group by sort of abstractly could make sense on a non-SQL database. If I were designing a Django-like ORM that's very object-oriented, centered around Python objects, I would design it with sort of not working with a SQL database in mind. And I guess 2 summers ago, I worked on sort of building a prototype MongoDB backend for Django, and it was sort of a mixed bag. For a long time, people have said sort of the Django ORM's like query code is really scary, like the ORM is the scariest piece of code in Django. And I think they're half right and half wrong. Part of it is it's really scary because it's solving like a pretty complex problem, and so the code will inherently be scary no matter how perfectly it's written. And the other half is it's scary because it is a little messy, because these layers are not well defined. The SQL bleeds into the distinction between an F object and when you use a keyword argument, stuff like that. So if I were designing an ORM with Django's philosophy today, I would definitely build it with a non-relational database in mind. Great, well, I suspect I'm out of time by now, so thank you guys.
All right, so as we were switching, and we'll probably take another break, the